Hello, and welcome to the presentation on Basic Math Facts, the role of computational fluency. Today's presentation will explore the role of mathematical fluency under the Common Core. When most people think of math facts, they think of the Mad Minute. The Mad Minute is a strategy that was used previously to the Common Core to assess students on their ability to quickly and easily find answers to math problems. Typically, you would see the Mad Minute in multiplication facts, and students would be timed to see who could get the most correct answers in 1 minute. The next slide will show an example of a Mad Minute, and we are using this example to demonstrate why we are moving away from the Mad Minute with Common Core assessments. So get ready, you're going to have a chance to take a Mad Minute test. See if you can get as many answers correct as possible in 1 minute. Ready, set, go. By now, you've probably realized that these problems don't look like typical math problems. For a student who doesn't have a solid base understanding of math facts, this is how a Mad Minute can look. And the added time pressure of the Mad Minute can make a student feel very overwhelmed and discouraged from taking on math. This is why we are moving away from memorizing facts, and instead we are moving toward conceptual understanding based in computational fluency. Under Common Core, fluency is defined as follows. Computational fluency refers to having efficient and accurate methods for computing. Students exhibit computational fluency when they demonstrate flexibility in the computational methods they choose, understand and can explain these methods, and produce accurate answers efficiently. The computational methods that a student uses should be based on mathematical ideas that the student understands well, including the structure of the base 10 number system, properties of multiplication and division, and number relationships. We want students to move away from memory tricks and instead base their fluency on understanding of the numbers and what goes into a calculation. For example, a student who is flexible in their computational thinking may know that multiplication is the easiest way, the most efficient way to solve 7 times 3. But if they're unable to retrieve that math fact, they also understand that they can use repeated addition to come to the same answer. We also want our students to reach a certain level of automaticity. We want them to effortlessly recall facts so that the math facts don't get in the way of their higher level thinking. Below is a picture of an MRI. On the left-hand side, we have a brain of a person who is walking and chewing gum for the first time. On the right-hand side is an MRI of a person who has been doing both tasks for a long time now. When our students begin to do higher level mathematics, they are essentially doing 2 tasks at once. They are tackling the higher level skill, whether it's graphing or calculating volume or solving a word problem, but they are also retrieving their basic math facts. They need to demonstrate fluency in the calculations in order to move forward in math. If their brain is that on the left-hand side of a student who is not familiar with his or her math facts, it is very difficult for that student to move forward and do more complex tasks. On the other hand, the brain on the right would represent a student who is very fluent in their math facts and doesn't need to use tricks and tips and count on their fingers to remember their multiplication. Instead, they are able to recall those facts quickly and move on with the complicated math task at hand. So here we have an example of why it is important to understand, not just memorize, math facts. Which is easier to remember, number 1 or number 2? Most people find that the second sentence, a little girl sat in the red chair, is much easier to remember. There's 2 reasons for this. First of all, most of us can imagine a little girl sitting in a red chair. That gives us a visual image to go with the sentence. Secondly, many of us have encountered a girl sitting in a red chair before, and that gives us context. So when we want our students to be able to recall their math facts, we want them to have both a visual and a context. Given this, you will see students drawing out their problems, drawing arrays with circles and rows and columns to represent multiplication. And you will see them using story problems to build context around their math facts. At this point in the presentation, we show a video. There's a link here to the video. Only the first 2 minutes and 55 seconds were included in the presentation. If you would like to watch the video in its entirety, you can simply enter the URL seen here. The video references Common Core fluencies. Under the Common Core state standards, there are stated fluencies for each grade level. This chart shows the grade level and the required fluency. As a reminder, this is a required fluency for the end of the year. So for example, multi-digit multiplication is expected of fifth graders to be fluent, so they're not using drawings or using algorithms, by the end of their fifth grade year. Now, fifth graders will also begin to work with multi-digit division, but it will not become a required fluency until later on. Why is it important to understand math facts? The first example, understanding 7 times 3 as 7 groups of 3 items, provides that visual that we talked about earlier. Students who rely solely on memorization and tricks confuse similar facts. 9 times tables are historically very difficult for students. However, if they have a conceptual understanding of multiplication, they can use related facts. 5 times 10 equals 50, therefore 9 times 5 cannot be 54. It needs to be less than 50. So as we move away from this memorization and we move toward conceptual understanding, what does that look like in the classroom? Well, here's an example of addition. Oftentimes, our very young students practice the idea of doubles and doubles plus 1. So while we know that 2 plus 3 equals 5, very quickly 2 plus 3 becomes 250 plus 310, and we want our students to be able to tackle this quickly. So one way to do it is to take a double of a number and add 1. So if you didn't know that 2 plus 3 was 5, you knew that, the double of 2 plus 1 is 3, plus the previous 2 would give you 5. In subtraction, 14 minus 7, you could use your doubles and see that the double of 7 is 14. If you didn't know this, you could also use the make 10 strategy. So if you have 14, you can make 10 by taking away 4, and then out of your 7, you have your number bond there. You minus 3, and you end up with 7 as your answer. In multiplication, you also see students break apart one of the numbers to work with easier math facts. So 4 times 7 is the same as 2 times 7 plus 2 times 7. And in division, we have an example of 91 divided by 7. 91 divided by 7 would typically require a calculator or long division. But students who've practiced the number bond from a young age can break 91 into 70 and 21. So 70 divided by 7 is 10, plus 21 divided by 7 is 3, and you get 13. Sometimes this strategy is also referred to as partial products. So a lot of kids benefit from practicing these activities at home. Here's an example of a game you could play with your kids. You can roll dice to generate a story problem. So if you know you're putting fish in fish bowls, for example, you could have your child roll the dice once, and that would be the number of fish bowls they have. And then have your kids roll 2 dice to see how many fish will go in each bowl. If your students are able to visually represent that story problem, they could also write a word problem and explain how they would solve it as seen on this slide. Thank you for listening and watching with us today. For more information as well as some more activities you can try with your students at home, please visit the virtual handout for today's presentation, either using the QR code on your screen right now or the shortened URL displayed below. Thank you.